All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We're going to pick up where we left off on the last stream. We want to talk about something real quick also before we get underway, because we're actually going to be starting something new tonight. Well, new-ish. So we've got that. Before we do jump into that, though, I do want to just take a quick second and thank the supporters of the channel, starting with our partners at the top there. They are the highest tier of subscription over on YouTube memberships and Patreon. Their names are Dustin Punt, Gabby Bashir, and Gerboles Inc. I would also like to thank all the other supporters listed here. They are a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me cover costs associated with running the channel and thus this project. So thank you very much for that. All right. So I hope it also goes without saying that I appreciate each and every one of you viewers, whether you are joining me live here, either on the Twitch side or the YouTube side. We do simulcast to both. So this is an interactive stream, so I do encourage you guys to interact and stop in, say hello. If you have any questions or whatnot, feel free to ask and we'll discuss. Otherwise, if you're catching this on the VOD, I appreciate you guys too. So obviously, without all you guys here, this project would not exist. So thank you guys for being here. Thank you for interacting. And thank you for generally being awesome. Okay, so with all of that out of the way, I think we can jump into our discussion. From Lake, good to see you. Something new, soft body dynamics top priority. No, we're not there yet. So we are going to be talking about the resource system tonight. So we have been working on the asset system, the packaging, the virtual file system. We've got those things relatively done, or at least done enough now, to where we can actually start on the resource half of it. So we're going to touch on that. But before we do, I do want to just kind of touch on something that we kind of left off on last night. And I wasn't 100% sure that I was sold on the implementation when we ended the stream, and thus I was not. So we actually have come up with a final solution. And this is going to be a pattern that I think I'm going to use quite often for some of our other container classes as well. So what we're looking at here is the new version of array.h. And I completely rewrote this from what I had on stream last night, just because I kind of had, just a brain fart and just kind of like, oh, I should have done it this way instead. So what we have here is a statically sized array along with an iterator, right? So this is actually a dual purpose thing that we have going on here. And this is about as close to generics as we can get in C. And so the way that this works is we have this big, giant define, right, that basically encapsulates all of this. And what you do is you pass in a type, right? So that's the actual type of array that you want to create, and then a name for that. And the name can be different from the type or can be the same as the type depending on what you're doing. And so the general idea is that we type def a structure using the name, right? And then underscore array. So we type def that, that has the length and stride in it, and then also a type pointer, which is the underlying actual block of memory, that actually has the data, right? So it uses the type for the actual structure name. It uses the name for the structure name and the type for the actual type of data that we're dealing with. Same goes for the iterator. So the iterator itself is another structure. It just is the same name as above, just with an underscore it added after it for iterator, just because typing iterator seemed kind of ridiculous here. And basically what it has is a pointer to that named array type, right? So a pointer to one of these guys, and then a position within that array. And so we'll cover that in just a second, but I figured I'd cover both structures while we're here. Code Wonderland, thank you for the follow. Appreciate that. So The next thing that we have is we have our create function, which goes ahead and creates that name typed array here and returns it, and then calls this k array init. And basically all this does is it just shifts the allocation to the C file, essentially, right? So we can keep this stuff out of the header file. So essentially what this does is it takes in a length and a stride, and then a pointer to a length, a pointer to a stride, and a block of memory. It basically sets the pointer's value to length for out length, the pointer's value to stride, out stride, the pointer's value to block to the newly allocated block of memory, and then the free just basically undoes that, right? Now, why did we do it that way? There's a very good reason. Because it keeps all of that stuff out of here because these are inline functions. They must be because this is in a header file. And so these are going to be inlined, and I didn't want all of that logic to necessarily get inlined, right? So this way it keeps the inline portion very, very succinct, right? And it can just reach out to this, and we don't have multiple copies of this laying around. So the way that this works is we pass in the, obviously the length, we just pass that through. When we create the array, we specify the length. We use the size of the type, just kind of like we do for our D array. And then we pass through the array length, right? So that's the structure up here that we created. We pass through the address of that and the stride. And then of course a pointer to the data array, right? Casted to a void double pointer, right? So that's the way that works, and then destroy basically works how you would expect it would. We pass the pointer to the length, pointer to the stride, pointer to the array data to destroy that. And that's really all there is to the actual array itself. It's actually pretty simple, and all you can do if you want to iterate it sort of the traditional way, you just say the array dot data, and then that gives you the actual underlying array if you want to iterate it like a C array. That being said, for those of you who prefer iterators a la C++ style, think of vectors and things like that, we do have a iterator for that as well. So this one goes ahead and creates an iterator using that secondary struct that we have up here. And all it needs to begin that is just a pointer to the array that it's going to be iterating. So it saves off that internally, right? So here, and then starts off at position 0. And we basically can just do, a check here for iterator end, which basically says, is the position greater than or equal to array length? And then that'll return true or false based off that. We also have just a little function here for array iterator value, just to easily get that. We could also, utilize the position here to index into this array here to get that information, but this just kind of wraps that up in a neat little function. So we can just pass a constant pointer to the iterator here, and it will do that indexing for us and return a pointer to that data. And then we have next and previous, which they basically just move the position internally within that iterator. And then the next time you go to grab the value, that's how that works, right? So overall, it's pretty simple, right? But the power of this comes in the fact that we've separated the creation of the type and the creation of the actual array and iterator itself. So what I mean by that is we also have another sort of shortcut macro here. So this whole thing is array type name, right? Where we provide both the type and the name. We also have just a array type here that just takes the type and uses the type for both of these. So here are some examples of where we'd want to use each, right? So I've gone ahead and created these types for our basic types that we have throughout the system. So our Booleans, all of our unsigned integer types, our signed integer types, and then our float types, right? And so what we get if we actually expand this, let's use U64 as an example. So if I expand this out, what we get is this in our final expansion, right? So we have U64 underscore array, right? So it creates that type for us. Here's the underlying array. Here's the iterator with a pointer to that same type of array, right? And then here we have the creation for that, which has all the correct typing information in it. The destroy for that with all the correct typing. The iterator begin, of course, with all of the correct typing for that. The end here as well. The iterator value next previous, right? So it wraps all of that up in nicely typed information so that we can use that. The named, where we'd want to use that, is for more complicated types, right? So these are kind of basic, where we just have B8. We don't really have to think about it. But what if we want like a constant character array, right? A string. These macros would not work if we just passed constant character star into that, right? That would not work. So the name allows us to specify something else that could represent that. In this case, I chose the word string. So now I can say string array, and it will create one of these structures and the iterator for the type of const character array. So if I expand this guy, you'll see here that if we go down here to expands to, we can see here that we've got all of that set up, right? So it sets up our double pointer for us here, right? We have our string array there, and so forth. All of these types are in there, as you would expect. So it's very convenient to use. And the nice part is everything is very type safe this way. So it's very easy, especially if you're using the iterator, to not have to worry about bounds checks and things like that. So that is what I'm going to wind up doing. So we have this array, which is this is a dynamically allocated static sized array, is what I'm calling it, right? So it never grows, it never shrinks or anything like that. When you create it, it is what it is. This is dynamically allocated, though, meaning we do have an allocation call. It's created on the heap, right? I'm going to create alternate versions of this. I'm going to create another version that I'm going to call probably stack array for smaller data types that you don't necessarily want to dynamically allocate memory for. And it'll essentially wrap that the same way if you wanted to do that. And then I'm also going to create a new version of the dynamic array that follows this same sort of pattern. Of course, with extra, push, pop, all of those additional functions. So I'm going to basically get these. I'm going to implement those off screen. I don't think you guys need to see me write all of that stuff. This is basically the way that that's going to work. And we're going to start using that going forward for those types of situations. The first place that I've used this is actually in the system. Was it the system font serializer? No, it was the bitmap font serializer, I think is where I put that. Bitmap font serializer. So if we take a look at the kasset bitmap font, we'll see down here, we have these different array types here, right? Which these are a little verbose because we're dealing with verbose, structures, right? But we can use them on custom structure types as well. So, it automatically creates these types for us, and then we can just use them like this. No maintaining separate counts or anything like that anymore. Everything's wrapped up into a nice, neat little package. And then in code, we can just, access them using these create functions, iterate them as needed, and so forth. Now, there's nothing in here that uses the iterator. I don't have an example of that yet, but I'm sure we'll come across one tonight. So let's see. Noob question: why the row of backslash on the right? Not a noob question at all. So a define is a preprocessor macro, right? And what that's doing is basically saying, take any instance of this right here, this set of tokens, right? Any instance you find of this in code, and replace it with anything that comes after it. But that's limited to one line. So what this is doing is this is basically saying, I know we've reached the end of this line, but I actually have more that I want to include in the next line. So count the next line as part of this line as well. So it's an escape sequence to say, include this next line also as part of the thing. And so that way I don't have, some gigantically long line that you'd have to scroll left and right because nobody wants that, right? So this allows me to have this nicely formatted and be able to include it all under that one single define. So this define, this one single define, actually wraps all of this. So when we take a look at this array type here, and we expand that out, right, that becomes array type named, right? And then that expands to all of this, right? So that's the way that that works. Hope that makes sense. All right. Final solution. Yes, that is the final solution. Smudge, how's it going? Good to see you. Welcome, welcome. Let's see. Hello, I've seen people use NeoVim before, but I'm a classic Vim user. Why would you say you should make the switch? For me, it's the plugin availability. Also, being able to configure in Lua is kind of nice. I don't really use Lua for anything else, but it's a lot easier to work with than VimScript, I think. And I've used both, but I much prefer Lua, I think, just for, you know, ease of configurability. It's a lot easier to read, and there's plugins that are written for NeoVim that don't exist for Vim. So that's, I guess, my main reason for using it over regular Vim. Okay, so with all of that out of the way, that is that. We've gone over that. So now we're going to talk about resources tonight. So up to this point, we have been doing a refactor of the asset system. We created a package manager, which is to package up our assets and be able to load them from disk, or be able to eventually create a huge binary blob that contains all our assets and be able to load from that and catalog it and stuff. That second part we still have to do, but we have the load from disk portion of that working for now. On top of that, we put a virtual file system, and then we set up our asset system to actually use that. And so we have this separation now that we didn't have before with our previous, or I guess our existing resource system, where assets are basically things that we load off disk that aren't necessarily going to be used as that final form when they're uploaded to the GPU or whatever. There might be more processing we need to do, or other things that need to happen to it, or maybe it's part of something else, right? Maybe an image asset becomes a texture, but maybe it's also used as a lookup for a height map, right? So we've separated all those things out. And so we're done with the asset portion for now. There's a couple of assets that we have to tweak, and there's a few more tasks we have to do in there, but I think we're far enough along now where we can actually start looking at the resource system and start sort of taking that apart and redoing our resources much in the way that we did assets. And so if we take a look at our resource system, our resource system right now, like a lot of our systems, has a config, right? And it deals with loaders. So these loaders are the things that would load stuff off disk, right? So that concept is gone. Resource loader right here, right? This is to load stuff off disk. This is no longer going to exist. We have, loader registering, resource system load custom, like this whole load versus load custom, that thing's going to be going away. Resource system write, base path for type, like all of this stuff is tightly coupled to, writing and reading to disk, right? So we don't want to do that. And then we also have something here that's just like, oh yeah, by the way, we can also unload resources, right? So we can, the primary thing that we want is, we have the load and unload. And so we have all this other stuff that the resource system does. And as a result, what I'm going to say is, instead of trying to refactor this resource system into something that does what we need it to do, I think it would be far more prudent to write a new resource system that handles things the way that we do it, that we want to do it, and also rewrite our resource types while we're at it. I think that makes things make a lot more sense, and it'll allow us to hopefully be able to introduce these changes a little at a time. So like we'll be able to, I don't know, load up texture resources, right? But like keep everything else loading the old way, right? And we'll just hopefully be able to migrate one system at a time. So I hope that makes sense. Yes, it helps. Thanks a lot. Puts define in a whole new light. Awesome. Okay, cool. Cool beans. All right. So we have this called resource system. And we technically, we're going to need something else that's also called a resource system. But I obviously can't name it resource system. And so I guess the question becomes, do we call them resources? Is there some other word that we can use? I guess that was something I didn't think about off stream that I probably should have. So I'm going to quickly do a thesaurus search for resource. Let's see. So usually there might be something in here that we can use as opposed to like the term resource. I just want to quickly look and see if we can actually find something, right? Let's see. It's funny they list asset in here. Let's see. I don't think any of these really fit. So resource is probably what we're going to stick with. Okay. Yeah, none of these really fit. Nah. Okay. Nest egg fits the best. Yeah, right. No. All right, so that's a fail. I guess we'll stick with resource. That's fine. I'd be going to sleep in a couple of minutes, but I'm still up, so I might as well say hi. I appreciate that. Good to see you, Mr. Mustard. How are you doing otherwise, besides tired? Okay, so resources. So resources definitely don't belong in core because those are something that really only the runtime uses, right? Where assets are something that could technically be used by, external tooling, things like that. A resource is really something that's only used by the runtime. So I think it makes sense to go ahead and put this in runtime. I don't think it belongs anywhere else. I think we can safely put that in here. Let's see. We do have, unfortunately, we have resources already masked off here, which is not great. So we may have to do, I think similar to assets, I think we're going to call these K resources. Right, we'll just prefix K on there, and that's how we'll differentiate it. Unfortunately, I may also have to say K resource system to handle that. Did we do, let me look at one thing, because I think it was just in core, just to be consistent. We did do K asset types. So we're going to wind up having like a K resource types and a K resource utils and that kind of thing too, I think. Okay, so let's start, instead of assets, I don't really, let's see, resources. Because see, like we have a lot of stuff under resources. And eventually all of these are going to be going away and they're going to be replaced with the new version of the stuff we're going to add now. But until we actually replace those, I don't know that I want to mix the new code in here. So I might, let's create a new folder and we're going to call this K resources. I think that makes the most sense. And then to this, we'll add K resource types header file. And then to that, we're basically, this is where we're going to put all of our once. We'll include, I guess, let's go ahead and just include math types because I know we're going to need that. So we'll do math types. We might even need geometry 3D. We'll see. And so basically we can kind of use this resources folder here as sort of a template as to what we're going to do. So my immediate thought is we're probably, I guess we'll do, let's see, which one should we do first? I feel like textures is pretty ingrained into a lot of things, so I'm hesitant to do that first, but thank you for the follow. But maybe it makes most sense to knock textures out because there's some other things that I wanted to do with textures as well. Let's see. From now on, K nest egg is the thing. I might put it in there as an Easter egg. Okay, not the best. I've had worse days. I get that. I totally get that feeling. More than you realize. Let's see. Checked your repo for a reference and noticed that platform window title set on the Windows side has an error. It sets the same title as it was before, not the new title. Oh, that's neat. Title set, rather. Okay. Womp womp. Yeah, there it is. It's using the window title. What a dingus. Okay. So that should definitely be just title. And of course, I'm looking at this without any sort of highlighting or anything, so I hope I got that right, but I think that's all it's needed to fix that. Thank you for pointing that out. I appreciate that. I don't think I'm actually using that anywhere. I just kind of set the window title when I start up and then don't really change it, but eventually when we start doing like opening projects and stuff, I'm going to be changing it. So I think that should be all that we need to do there. So I'll write that in there. Okay, cool. Appreciate that. All right. So we should probably also add a file for our resource system, but I think it makes sense to sort of work through some of the resource types before we actually do that, because otherwise writing the resource system interface without any types whatsoever is going to be kind of weird. So let's type def a struct, and we're going to call this kResource. And this is going to be sort of the base of everything. So it's going to have some base properties. We're going to want a kname, which that needs to be that. All right. So we want a kname. We're just going to call this name. Let's see. What are some other things? We need a resource type, right? So we need type def enum kResource type. kResource type. And actually, you can look at resource types. I'm actually going to steal this and just rename it, because this has a lot of what we need actually already. So let's put this in here. Let's get rid of this. Let's see, resource used by loaders outside the core engine. I think I'm going to leave custom in there, but we're going to kind of redefine how that works. So let's move this up here. And let's have a look at each one of these types to make sure that they actually make sense, because not all of them do. But first we have ads. So we definitely got a break for those. So is the plan to gradually replace every resource with a K resource? Yes. And we're going to standardize the way that those are all organized. Excuse me. But, obviously after ads, because Bezos has got to make his money. About halfway through ads. Sounds like a long refactor, not going to lie. Yep, it's going to be. It already has been, though. So it is going to be a long refactor, but we're also going to be cutting out a lot of code as well. And we're going to be getting rid of a lot of like non-standardized stuff because all of our resources now have been kind of ad hoc. The loading's been kind of haphazard, right? Because again, a lot of that early like tutorial format type stuff is rearing its ugly head, right? And so we want to get rid of a lot of that code and standardize how we're doing that. And this is why we're doing it now. Because I have more resource types and more asset types I want to add. And I don't want to keep adding those types and just making this refactor like kicking the can down the road and making it worse and worse and worse, right? So I'm biting the bullet and doing it now and getting it out of the way. All right, so ads are done. So resource types. Now when we talk about resources, we're talking about things that can actually be used maybe to upload to the GPU, like or loaded in some fashion. So it would be like a texture or a font. I guess a font itself isn't really, the font itself, I guess, doesn't really get uploaded to the GPU, but like the texture associated with it does. And then it stores a bunch of glyph and kerning data and stuff like that that's used to render it. Things like a terrain, all these kind of what we have here plus a few things. So I think what we're going to do, some of these don't make any sense anymore. So we're going to remove those and or rename them. So a text resource, like I feel like a text resource and a binary resource, like those are really just assets. I don't think we need to hold on to those. I think let's just get rid of those. Resource type image doesn't make any sense because a image is an asset, not a resource. So what we have here is a texture, right? Which texture is actually not in this list, for example, right? That's like a renderer thing, which it shouldn't necessarily be only a renderer thing. So texture, right? A material is definitely a type of resource, right? So we want to keep that one. A shader is definitely a type of resource. A mesh is, but there are going to be a couple of these. So we're going to have a static mesh, right? So our mesh right now is just called mesh, but that's going to be become static mesh because we are also going to have like skeletal meshes and things like that. So let's call this static mesh resource type collection of geometries. And we don't really use the figs anymore. So we're going to say geometries, right? Same with more accurately shader config. That is not the case anymore, right? This is a shader resource, and we are going to use that to actually manage the individual shaders themselves in conjunction with the shader system. So we have a static mesh. We also want to add to this a skeletal mesh, right? And that may wind up being renamed. I haven't 100% figured that out yet. But it's basically like a mesh that has a skeleton assigned to it, so you can like do bones animation and things like that. So we're probably going to be adding to this list, of course, but I'm just trying to kind of think now of some of the things that we're going to do. So bitmap font and system font, we're going to keep those because those are assets, but they're also resources. We have scene here, which for some reason has some sort of weird capitalization. So let's do that. That is called simple scene, is no longer simple scene. We don't call it that anymore. So scenes are a type of resource. Terrains are a type of resource, but we have specified that those are going to be height map terrains. And that's because we are also going to have a separate type of terrain as well. Based terrain. We're going to have, you're going to have, voxel terrains as well. We are going to have those, so I can go ahead and put that in here. We may not create it right away, but I do want to get it in there. Now, we have audio resource types, and we also have music resource types, and those are actually treated separately. So let's get them in here separately. Music, right? So music. And maybe we say audio effect, right? Because that's really what that's designed to be used for, some sort of sound effect. Maybe actually, let's call it sound effect. Right, sound effect. Music is like treated differently, right? It's even treated differently in terms of how we play that. Custom, I guess, could be an extension of this, right? For like user-defined types. I don't quite know how we're going to handle that just yet, but we'll see. Let's see. The image still looks kind of flat. What is missing? Not sure myself. Specs. Shadow, light variation over an area. Ambient noise, light fall off. Which image are you talking about? Did say last night you wanted to add skeletal animation to the game, to the engine for the game. Yeah. So that's definitely something that we're going to be doing, right? I just don't know if we're going to call it skeletal mesh or not, or skinned mesh. Could go either way. Oh, the I'll be back image. Yeah, it's a little bit old, but it doesn't have the best lighting setup. Like, it literally is just being hit with a directional light, and that's it. I don't have any sort of additional lighting going on there. Of course, there's not really any screen space, ambient occlusion, or any of that other stuff added either. There's no global illumination. Like, we still have some work to do on the lighting, for sure. There's a lot missing from it. When I said we've got PBR, I mean we do have basic PBR, but that's, there's still a lot of things going that need to be added to it. We don't have post-processing either, like Bloom. Let's see. That made sense unironically. What? I guess I missed the context on that. What did I say that made sense unironically? Okay, so I guess we'll leave this here, but we'll say used by for resource types defined outside the core engine. Because we'll eventually have other resources that maybe are user-defined resources, for example. And this list is going to definitely be much longer than this. I think the other thing that I'm going to do is I'm also going to do, and I'm going to actually say k resource type here, and I'm going to say count, right? Just so that we have that in case we're iterating them for any reason. So with that, I'm going to go to here and insert right? Insert a K here. Oops. Right, because we're calling this k resource type, right? So we want to be explicit that this is a different enumeration because we're going to be removing that other one. Okay, so here's our k resource. So obviously we need our k resource type, so we can add our type there. Let's see. Some of the other things that we're going to want to include on a basic resource. We are going to want to have a generation, right? How many times the thing has been loaded. We may need to know that for resources like textures, for example, where if the renderer backend has a different generation than the actual resource does, then that means we need to re-upload the texture, for example. Okay, let me think. So name, type, and generation. I suppose we could also do... Should we have some sort of reference to the original asset, or at least its name? Like maybe that. I don't know if that makes sense. You know what? I'm not going to do that there. And the reason I'm not going to do that there is because some resources might have multiple assets associated with them. And then that becomes weird in that case. So I think I'm just going to stick with this. And then if we want to include asset sort of metadata, then we can do that. Speaking of metadata, we had some stuff over in our core assets. We had metadata in here. I don't remember all of what I put in there, but let's see. So we had ID. I guess we could do this. I don't know that I'm even going to keep this for assets. Kname kind of replaces that a little bit. What did we have for metadata? I don't know that. I suppose we could have some sort of tag data, right? We probably want that. Let's go ahead and put that in there. That's actually a good thing. So I don't think I'm going to bury that under metadata, though. I think I'm just going to put it here. All right, so we'll have the ability to tag it, and then we'll also have the ability to search by tag. All right, so I think this is a pretty good spot to start, right? So if we start thinking about actual resource types themselves, we're going to kind of follow a similar pattern as to what we did for assets. Stop it. There we go. All right, so we're going to do, I guess, let's take a look at texture, for example, because I think that's the first one I'm going to want to tackle, and that's actually... Now that I think about it, that's under render types, I think. We can clean up a lot of this stuff too when we go to load this stuff up. Let's see. All right. I guess I need to be more specific. Struct texture. Really? Where is this defined? I don't even remember now. It was in here. Why didn't it find it? Okay, whatever. All right, so we've got let's see, an ID, which I don't think we're gonna need. Texture type, width, height, channel counts, array size. Okay, so I think what I'm gonna do, I'm just gonna actually take this for now and copy it as our first example. Here we go. We're going to refactor it a little bit. So we're going to call this... I hesitate to do k-resource texture. That seems a little verbose to me. Especially for like k-resource height map terrain. But maybe that's not so bad, I guess. I don't know. All right, I'm not going to overthink it for now. I'm going to roll with that for now. If we want to rename it later, we can. All right, so we have K resource texture. We're going to get rid of that. We're not going to have an identifier. The first thing in here actually is going to be a K resource base, right? So that's always going to be the first, just like our assets, it's always going to be the first member. And that allows us to take a K resource texture and easily cast it to a K resource back and forth. You know, we can access the data that way very easily. So that all makes sense. We have a couple of types in here. Let's see, we have texture flags, we have texture type, and a handle to the render texture handle, which I'm actually considering removing, believe it or not. But we'll come back to that. Let's see. Let me catch up with some comments here. It looks like I've got some stuff. Speaking of which, I'm not on Discord, but I'd vote for a simple arcade game. Just make a simple one and make them increasingly larger and more complex. I mean, that's okay. So that's fair. I actually haven't looked at the polls yet tonight. That's a good point. Let me pull that up real quick. So let's see. It hasn't really moved since last night, actually. But I'll take a new screenshot of it and show you guys that really quickly. So let's see. Pen. There we go. So we are taking this poll on the Discord server. So if we do a exclamation point Discord in here, I'll do this on both sides. If you guys will head over to that and then go to the polls channel, which I don't know if the YouTube bot is picking up on that. There it goes. If you'll head over to the polls channel and vote on this, I would greatly appreciate it. You know, yeah, basically the choices are like a small style arcade style game rather. It'll be 3D, not 2D. Just something very small and simple to sort of get our feet wet with publishing with this, right? Or screw it, start making the big game, which is the big project that I have in mind. Or neither, just keep adding stuff to the engine, which this has a little bit more traction than I thought it actually would, but there you go. So there is 4 days left on this, so the more votes, the better. So yeah, if you guys wouldn't mind, go vote. All right, so let's see. Working on a simple 2D platformer as a side project, and I'm working on a clicker game. Nice. Both an XNA / mono game. Man, I loved XNA. I was so mad when they killed that. Just stumbled upon your Kohi playlist the other day. It's awesome. Keep up the great work. Thank you. I appreciate the kind words. Thank you. And welcome. All right, let's see over here. Usually I merge ID U16 plus generation into a new OBJ-like handle. It's useful for other parts of the engine like pools. Sebastian Eltonen has a great presentation that touches on REAC 2023 high pipe. Okay. I had thought about doing something like that initially, actually. And we have a few different options within the engine to actually do that. These handles did work out pretty well, and I'm not completely mad at them. I just don't know. I don't know if I'm probably going to stick with it. Honestly, if I change to something else, I don't know what that would even be. So I'm probably just going to keep it for now. But yeah, we do have a handle system in here already. Okay, so texture types. So we obviously need to do. Let me open up. Actually, I think it was renderer types. Renderer types. This one. Let's see. texture type. Here we go. All right, so we've got these various types of textures that we support right now, which obviously this is going to be an expanding list too. I think we're going to do the same thing. Since this is under resource types, I think we're going to do the same thing and just take a copy of it and redefine it, right? So we're going to call this k-resource texture type, right? And I guess we'll call this, we'll do the same thing here. That's a little verbose, I think. Let's see. I think I'll go to sleep and watch the rest of the VOD when I wake up. Fair enough. I can appreciate that. Have a good sleep. It is a bit verbose. Again, it will make it very obvious as to what's using the old stuff versus the new. And again, I can do a rename on that later, so I think that's what I'm going to do. So let's do k-resource wow, I completely excuse me. So that's going to be the texture type. Width and height can stay the same. Channel count is going to stay the same. We should probably maybe instead of channel count, well, I suppose we could have a channel count, but I'm also thinking we should have a texture format in here, right? Or like, I guess it would be an image format, right? So like RGBA 8, for example. And we already do have, you know, the image formats that our assets use. But we don't have a lot of stuff defined there. And I'm thinking we could extrapolate like channel count out of that, for example. But it might also be nice to just access it directly. But then I really don't want to do channel count and then also a format, right? All right. Yeah, I guess we'll go ahead and just define that too. So type def enum k-resource texture format. K-resource texture format. We'll do again k-resource texture format. And I guess we'll do formats similar to like, I guess, you know, RGBA 8, right? So 4 channels, 8 bits per channel. You know, so we might wind up with a few others. We should probably default to something that's invalid or like unknown, right? So we'll say RGB A8, RGB 8. I don't know that I need to define all of these right now. We'll add them as we need them. So instead of this channel count, let's do a k-resource texture format. And then the format of the texture data, I guess. Array size, so that's for arrayed textures, right? So how many layers there are. Otherwise, this is 1. I think we'll keep that as it is. Texture flag bits. I don't remember. Let's see. Texture flags. We have a few things here. So whether or not the texture has transparency. So we figure that out on load. Whether or not it's a writable texture, whether or not it's wrapped, which means that its internal resources were created elsewhere and not it wasn't loaded traditionally. Whether or not it's a depth texture, and then whether or not the texture should account for renderer buffering, like triple buffering or double buffering. So I think we need to actually keep that. But again, we'll have sort of our own type for that. And we'll deprecate the old one, right? So k resource texture flag, right? And then k resource texture flag, right? I think that is just fine. Oh, did I? No, okay. Okay, so we'll do k resource texture flag bits. Oh, that's its own thing. That's here as well. Holds bit flags for textures. I'm going to do a U32 on this. I don't know why I did a U8, but let's do a U32 on that. And we'll do k resource texture flag bits. Okay. So we've got that. The texture name. Okay, so this, for example, we don't need any longer because that is provided for us in the base, right? Spiro with a raid of 41. Thank you so much for the raid. How are you doing tonight? And thank you for the follow, by the way. Hello, raiders. Welcome. I was hoping that my automatic shoutout would work, but it does not appear to have worked. So I was trying something with the bot, but let me do it manually. I'm trying to find a way to automate that. But if you are not following Spiro, he is a GigaChad developer here on Twitch, and he's always exploring all kinds of different things. Right now, he's actually doing a pretty in-depth exploration into some of the problems in the software industry as a whole. And it's really, really good information to have. So I highly recommend that you go follow him if you're not already. Thank you so much for the raid. And let me do my quick introduction here. So for all of you who are new, what we are working on right now is something called the Kohi game engine. And I will actually drop a link here in chat for you guys to the website that we're looking at now. So this is sort of the central hub for the project. So what the Kohi game engine is it's a game engine that is written completely from scratch using C and Vulkan as its initial rendering backend. When I say initial rendering backend, that is because it is one of many that we plan on supporting. We are also going to be supporting Metal and Direct 3D, probably 12 as well. So Vulkan is just the first. In addition, it is basically a project that is built almost entirely on camera. It started as like a YouTube tutorial series. We changed formats a few times and ultimately landed on this live stream format here on Twitch. So we have a YouTube and a Twitch channel. We simulcast to both. The project itself is open source. So if we go here, the GitHub repo is here. It is Apache 2.0 licensed, which means it is available for you to use either for personal or commercial projects. All that I ask is that you say you used it. That's literally it. There will never be any sort of licensing or royalties or fees of any kind ever. It will always be free and open source. The idea here is that this is a educational resource on a way to build a game engine. It's not the only way to build a game engine. Oh, did we just literally hit ads? literally hit ads in the middle of it. I didn't bat them away quickly enough. Dang it. All right. I will continue the spiel when we get back. Spiro! No, it's fine. I didn't see it either. I didn't realize we were that close to an ad break. Don't worry about it, dude. Yeah. It's only a minute long, so we'll hold off on the rest of the explanation until the ads finish up, and then we'll continue. So just bear with us for a moment, and then we'll get back to it, okay? And I'll explain my reason for doing that also once we are done with the ad break. All right, let's do that. So we've got about a little over 30 seconds left, and we'll get back to it. All right, almost done with ads. Ten more seconds. All right, cool. Ads are dead. So before I continue with this, I just want to mention really quickly, since we got interrupted by ads rudely, whenever ads come up on this channel, since it is a programming stream, I do like to pause the stream whenever those come up so that nobody misses any content, because nothing is more annoying than you're like right in the middle of doing some programming or following along or whatever it may be. We're in the middle of a technical discussion, and then it gets cut off by a full screen ad and you can't hear or see anything, right? So to avoid that, I just pause the stream for that 90 seconds because every half an hour we get up to 90 seconds of Twitch ads depending on region or locale. So I sync the ads between Twitch and YouTube as best as I can anyways. I have to do it manually, but yeah, that's the reason for that. So anyway, where we were with this is designed to be a educational resource. So this is a way of building a game engine. It is not the only way to build a game engine, and sometimes it's deliberately not even the right way to do it. And why I say that is because we explore things that work, we explore things that don't work. We also explore why they don't work. And in addition to that, we experiment with things on here. We try things to see if it will work, and sometimes they do and sometimes they don't, and then we have to refactor that, right? It's just a matter of the way that we do it, right? But all of that is in the guise of learning, right? It's to learn why things work and why things don't work. So we do deep dives in here. We sometimes have to skim over some things in order to kind of keep things moving. But anyway, that is basically the gist of it. So if you head over to Kohi Engine, we've got there a bunch of links, obviously, to our YouTube or Discord. The Discord is almost at 1,000 members, not quite yet. And then we've got the GitHub here. And if you like my work, feel free to support me on Patreon. I greatly appreciate that. It helps me cover costs, right? And then in addition, we have the stream going down here at the bottom. So I can, wave to myself on camera, and we have Inception. There we go. So yeah, that is that. So that's basically what we're doing right now. Specifically, what we're working on is we are refactoring our resource system. We just finished a major redoing of our asset system, splitting up resources and assets into two separate things, because before they were kind of one thing. And so we have our sort of old resource system that sort of kind of haphazardly combine those things. And a lot of that's left over from the old sort of tutorial format of way of doing things. And it, came with a lot of technical debt. When you're doing things in that fashion, you're trying to do them modularly like that. Sometimes it's not always possible to come up with a architecture that works across the board, right? So we're standardizing everything into a standard way of doing things, both for assets and resources. So we've got the asset portion of that done. That included a packaging system for assets, and that also included a virtual file system that we built on top of that. and then an asset system that is responsible for retrieving those assets through the virtual file system from the packages and so forth. So we've got all of that. And now we're working on the resource half of that. So you might be asking, what's the difference between an asset and a resource? Well, an asset is something that's loaded off of disk. So that would be like an image, for example, like a JPEG, right? Versus a resource, which is a texture, right? That gets uploaded to the GPU. Those are completely different things, even though they seem similar and there's some overlap there. They are actually different things. So they should be treated as such, right? So a resource shouldn't be responsible for being like loaded off disk, or shouldn't have to worry about any of that stuff. And an asset shouldn't have to worry about what happens to that data once it's loaded off disk, right? It's kind of handed over to a separate system that handles that. So that is more or less what we're working on now. All right, let's see. What's up? You implemented a virtual file system. Yes, we did. It's not complete yet, obviously, but we do have the workings of it, and it does sit on top of our packaging system. So right now, basically, it still points to files on disk, but we have an interface in place where we're going to be able to do a sort of, I guess you could call it like an Unreal style cooking of packages, right? Where you basically take the asset manifest that we have and bake all of those that asset binary data into a massive binary blob that contains like lookup tables and stuff, and that's what we actually ship, right? So you're not shipping like a whole bunch of loose assets just sitting on disk. You're shipping a nice contained package of assets that is then used by the virtual file system and indexed that way, right? So we have all those things set up. We still have to create that binary blob and that stuff, but that should be relatively easy compared to accessing all this stuff on disk. Let's see. For node system, I keep a reference of a parent pointer. By default, it's set to null pointer. You said you implemented a node system. How are you doing it? So if you're talking about the node system that I used in the scene, that's actually a little bit more complicated than that. And I'll go into it quickly, but I don't necessarily want to detract too far from what we're doing here, because we did cover it in greater detail in the past. But what I'll say is we actually have in our scene is basically, you know what, in fact, let me open up a scene file. Let me open up this one. So this is a custom storage format that we wrote as well. It looks a lot like JSON, but it's not exactly the same. So basically what this is, we have these nodes, right? So this is an array of nodes. This is an individual nodes, an individual node rather, and those nodes can have different attachments to them, right? So this particular node has a skybox and a directional light, which is, you can think of that as a sun, right? And then if we look here, we have another node here that has, it's called a sponza node, right? That's our sponza, contains our sponza. This one has a transform, right? So we actually have, rotation, scale, and position. Note that this one does not have a transform, right? So not all nodes have to have transforms. We'll come back to that. So this one has an attachments array with a single attachment in it, which is a static mesh, right? It also has children, right? So we can nest these, right? Which can have their own attachments, their own Xforms, etc., right? So the way that this works is we keep a flat list of nodes, and we keep a flat list of all the attachments and everything in the scene. And then we use separate graphs depending on what data we need. So we have a hierarchy graph that handles the nesting, right? Completely separate from how the nodes are actually listed here in the file. This just kind of helps to visualize it, right? In memory, they're actually in a contiguous array. But in here, in the actual scene, we have a hierarchy graph that is responsible for maintaining the parent-children relationships here. And then we also have a bit of an Xform system as well that works with that to determine transforms, world transforms, and whatnot. So you can have a node that does not have a transform, And in that, you can actually nest a node that does have a transform. And you can have anywhere in there, you can have a node that doesn't have a transform, even though the ones above it and below it do. And it just skips that node in the view when it's actually trying to actually calculate what those transforms are. Because it doesn't really make sense for something like this, for example, our environment node here, to have a transform, because a skybox doesn't have a transform, neither does a directional light, right? So that's more or less kind of what we're talking about. You wrote a parser for the scene file that looks like this. Oh, okay. Yep. Currently you don't use something like SFML does. Transformable drawable classes. You'll do it later. Fair enough. I hope that explains it though. Let's see. So kohi does not have a scene graph. Kohi accomplishes what a scene graph would accomplish via what I was just describing, right? So scene graph basically has nodes where you have, or entities or whatever it is that you want to call it, where they actually have pointers to each other in terms of parent and children. And you actually have like structures that are nested in a tree structure. We don't have that here. We actually have a hierarchy graph that is used to visualize that if we need that view, right? So let's see. Do you think you'll be able to author animations in kohi? That could be, it could be doable. I don't see why not. Do nodes have pointers to the children, or is there a separate data structure to maintain? Oh, okay, I answered that question already, I think, too. So yeah, we have a hierarchy graph for that. Anyway, so we are in the midst of refactoring our resources. So what we're doing right now is just kind of laying out what our structures are going to look like. Just a couple of examples of structures and how those relate to the sort of base resource that we have here. So our base resource has basically got a name, which this k name, for those of you who are wondering, is a hash of a string, right? So it becomes just a U64. And so the advantage there is no string lookups, no string comparisons are done with these k names, right? It's just an integer comparison, and it's lightning fast. And then if we do need the string, we can do a reverse lookup on it. So each resource has a name, a type, a generation, i.e. how many times that's been loaded, tag count, and tags, which actually we just put something in here that might be making that go away, but I'm not going to get into that yet. Right, so tagging is basically going to be an array of k names, right? So we could tag it different ways so that we can actually search through our resource system to get resources by tag if we wanted to. And so we have that, and then each sort of specialized resource, such as the texture, for example, will have this k resource as a base so that we can cast back and forth between those two structure types effortlessly. And then all of the specific information after that. And that's kind of what we're laying out right now. Let's see. Have you tried the CRTP pattern instead of having a lot of virtual functions in C++? Well, I'm not using C++, so I can't say I have. Yeah, this is all written in C. Since virtual functions are resolved at runtime. Yeah, okay, I gotcha. But yeah, we're not doing any of that because we're using C here instead of C++. We do use function pointers, but that's about as close as we get to that. All right, so with that, the last thing that we needed here is we are going through all these fields to make sure that they make sense. Because while we're refactoring how our resources work, we're taking those old resource types, redefining how they're laid out, and making sure that everything here makes sense. So I think we are down to MIP levels, which realistically, I don't think that does not need to be a U32. That could be a U8. No need for that many MIP levels. That's ridiculous. I can't see us ever having 255 MIP levels either. And then our K handle, that's going to be our handle to our renderer specific texture, right? So this is this is a resource texture that's used by the rest of the engine. And then we have sort of internal data that Vulkan would use, and that's our renderer texture, and that's handled by the renderer backend. So this is a handle to that. Can we can just include that, yes. So let's go ahead and do that. Actually, that might have been, I think we need to leave that down in its own. Actually, these should probably come first. Yeah, let's do that. Okay. So then we have generation down here. This is texture update. Okay, so this, again, we don't need because our base actually provides that for us. So we can access that very easily. So this is what one example of a resource would look like. So I guess the next thing that we probably ought to have is a string representation of the texture or the resource type. And the reason we want that is if we're ever managing some sort of configuration file of some sort that is in sort of raw text format, we want a way to be able to represent that, as well as maybe in an editor or something like that. We want a string that we can use to represent that type. And then, maybe we've got something that converts that to an enumeration. So let's go ahead and put right here above the, let me actually do it right here above the resource type itself. So we'll do a define, and we'll say k resource. Let's see, resource type name texture, and we'll just do texture. Good enough. All right, so that should be everything that we need for that single resource type. So essentially, as we tackle these resource types, this is what we're going to do, is we're going to come over here, generate the structures that we need, and then start generating the logic around actually getting these things loaded and so forth. So the next thing we actually need to create, now that we've got some things to work with here, is we need to actually create our new resource system. So our existing resource system would be under here, under systems. And this is our old resource system. We kind of took a look at that before. We're not going to be ripping this out yet. We're going to transition away from this one resource type at a time. So what I'm going to do here is we're going to add, and we're going to call this the K resource system. And essentially what we're going to do is once we are finished stripping out the old resource system, then we'll just come back here and rename this as the resource system and get rid of the old one. So let's just copy pasta this and change that to a C. And we'll come in here and do, of course, our pragma once. Let's see, we should probably do we want to expose the state externally? I don't think we need to do that. So let's do a struct. We'll do a forward declaration on this. We'll do k resource system state, right? We'll need to include, I guess it's going to be resources. Wait, where did I put that? Did I put that under resources? K resources it should be. K resources. K resource types, right? We're going to need that. And so we want to export this symbol, right? So we need the K API. And the first thing that we're going to do is we are going to have a B8. So we're going to return a Boolean, and we're going to say K resource system initialize. And we're going to need to figure out a couple things for this. So we're going to need a pointer to a U64. And we're going to call this the memory requirement. this is something that we do for all systems. We figure out how much memory we need. We let the engine allocate that and hand us the memory. So in this case, we'll do that, and then we'll say struct k resource system state pointer state. Excuse me. And then we also need some sort of system configuration for this, right? So we need to type def another, whoops, if I type it correctly. We need another structure type here, so we're going to call this k resource system config. K resource system config. And I don't know what we're going to necessarily need to put in this config for right now, so what I'm going to do right now is just do u32 dummy. And we'll fill this in as we figure out what we need configurable. So we'll do, let's see, we'll do const k system resource config pointer config. And that'll be our initialize function. Shutdown is going to be much simpler. So KAPI, this is going to be return type void, because if we can't shut it down, the only time this would shut down is when we're shutting down the engine. So if that fails, you know, what are you really going to do at that point? So k resource system shut down. And all we need to do here is pass in the struct k resource system state, right? And that handles that. Now, when we think about our resource system in general, you know, what's the life cycle like? What kind of updates is this going to get? So the first thing that we're going to need is we're going to need to say we want to create a type of resource. And that resource needs to have some information that goes along with it to say what data do we need for it, what assets do we need for it, what all do we need to hand off to the particular handler for that resource type for it to be able to do what it needs to do. So we need a generic way in the resource system to accomplish that. And so there's about a dozen different ways we can do it. And what I'm going to do right now is do the one that comes to mind first. And if we need to change it, we can change it. So what we're going to do here is we're going to do let's do a B8, right? And we'll say that's to indicate success or failure. We'll do k resource system. And we'll do request, right? And the reason I say request is because this is going to be, we're essentially going to, we're going to sort of scaffold the resource structure, as it were. And we're going to kick off some asynchronous processes that are going to be happening. So when we return out of this, that doesn't mean the resource is loaded and ready to go. It means that the resource has been requested, and that's as far as we've gotten, right? Which actually makes me realize something we forgot here. There was something here that I meant to do earlier as well. Let's see. I think it was k asset types where we had this. Didn't we have... Did I nuke it? I think I did. We have... here we go. We have this k asset state here, which we never wound up using because I realized it's more of a resource state than an asset state with a fix me here because this needs to be moved. We're going to move this now, because this is another piece that resources need. They need a state. So right underneath resource type, but before the resource structure, we're going to put right now it's called asset state, right? But this is going to be resource state, right? So resource states, and then I guess let's just do resource states, repeat that, and repeat that, right? Indicates where a resource is in its life cycle. Oops. Resource. I could do a find and replace on this, but I'm making sure that each one of these makes sense as I'm doing it. So we have 4 basic states of a resource is the way that I'm thinking about this. So we have uninitialized, which is the state that we get when we initially request the resource, right? When we say resource request, and uninitialize is what we have. Initialize means that the CPU side of the resource has been loaded. That means we've gotten an asset loaded, right? And we've taken that asset, pulled the data that we need from it, done any translation processing on that data, and now the resource is ready and finished with that asset and ready to move on to the next state, which if it is to upload to the GPU, it's ready to do that. In which case it'll move from initialized to loading, which is where we are in the process of loading that or uploading that data to the GPU. And then once that is complete, we will get a notification event that'll say, hey, this is loaded. And then once the resource state is flipped to loaded, then it's actually drawable or usable, right? So in the event of a texture, until we actually reach this last state, the texture is not actually usable. So what we would do in this case is as we're loading up a texture, we would be using the sort of default checkerboard texture drawn in its place until this sort of life cycle has completed, and then we can swap that out. So let me just do this resource. So I hope that makes sense. The CPU side of the resources. Let's just go with resources. Have been loaded, but no GPU uploads have happened. The resource is not in a drawable state, and I'm actually just going to do this and this, and then this and this. So this one is the GPU side of the resources are in the process of being uploaded, but the upload is not yet complete, right? Resource is not in a drawable state. GPU side of the resources are finished with the process of being uploaded. The resource is in a drawable state. Now, this doesn't just apply to drawable resources, right? This may apply to other things, other types of resources as well. For example, an audio file, right? The process to load that up is also asynchronous. So, we're going to have loading and loaded for that as well, right? But instead of being in a drawable state, it'll be in a, they still consider it audio rendering, right? So, let me catch up on some comments here. We do have ads starting here in a second, so we are going to be pausing for those here as well. Let's see. Sergeant Pepper, good to see you. Seems NeoVim has good integration with the Cling format. It does. I love bloat and continue using CLAN. That's fair enough. I mean, I love NeoVim. I switched to it, was it 2 years ago now? Never really looked back. It is a CLI editor, yep. This looks really nice. Which TUI framework does it use? It runs in the terminal. So I don't know what it uses under the hood, but yeah, it just runs in the terminal. I think it's probably its own, yeah. if I had to guess. All right, there's the ads. So we will pause for ads, and we will be back here in 90 seconds. I'm going to take this chance to hydrate. You guys should do the same if you can hear me. It does. It does have its own TUI. I figured it did. Yeah. So we're a little over halfway done with ads. Almost done with ads. All right, we are done. All right, so Valaris1, first time chat, welcome. Says there's so much waste in terms of instructions executed by the CPU caused by patterns people follow blindly. Oop. He didn't say that, I did. And then today I was asked to create a getter and setter functions in C++ for a variable that had been public, which now they wanted to make private, but why? Okay. However, they didn't realize that these functions wouldn't provide the level of encapsulation they were aiming for. So that's the most frustrating thing, is like when you have people that are telling you you have to make these changes, but they can't like reason about the actual problem that they're trying to solve. Getters and setters is such a weird anti-pattern that is overused all the time, and it's really, really super frustrating. So I feel you on that one. Like, why are you going to take something that's already public and turn it into a getter setter? Oh, it's going to be modifying some state. Should it really be doing that? Probably not. Yeah. Thank you for the follow, by the way. Let's see. Yeah, so they do have their own TUI. I figured that. Let's see. Here's a fun little tip for anybody that gets ads. If you have a browser that lets you pop out video players, you can pop out the video player that appears above chat and turn up the volume on it and watch the stream during the... Oh, I didn't know that worked. That's pretty cool. Welcome, by the way. Although a lot of people aren't going to know that, and if you're on a phone, that's definitely not going to work. So, but yeah, I like to just pause for ads, right, so that nobody misses anything. It's doubly frustrating when they're architects. Yeah, I agree. I once had somebody try to tell me that comparing strings in a database was faster than comparing integers. Architect, right? That's all I'm going to say about that, but yeah. Yep, that was a thing. All right, so I think we're caught up on chat. All right, perfect. So we have these states. This is going to be very important for the way this works, right? Because I want to keep all this stuff very asynchronous, so that we don't have lots of inline code that's just sort of running in the middle of an update loop or something stupid like that, right? All of this stuff is going to be multi-threaded. A lot of it already is, and so we want to maximize on that. So I guess what we can do is write. So in order of importance, we have the k resource state here, right? So first we need to know the name, then we need to know the type, then we're going to want to know the state more often than anything else, I think. generation makes sense after that, and then, you know, tags and stuff like that. We could make like a metadata thing about that. We might make a metadata structure. I'm not going to add it for right now, though. We're not even going to set up the tags for right now. I just want to get it in there so I don't forget about it. All right. So let's go back to our K resource system and think about this request, right? So the first thing we're absolutely going to need, we know this, is going to be the K resource, right? We want a K resource pointer. We're going to say out resource. And that's going to be what we're going to write to. So the first thing that we do when we kick off a request is we're going to fill out a resource structure. And whatever is making the request is going to be the owner of that. And we're simply going to write some data into it. So the next thing that we're going to need to know is we're going to need to know some sort of information about how to actually load that resource. And so generally speaking, when you request a resource, let's see, you're going to want to request a resource probably by name. So we need a K name. And yes, I know you could fill that out here, but I don't want this to be responsible for, I don't want the caller to be responsible for doing that. We'll do that. We're going to need, let's see. So we might have resources that require one asset, which is easy, right? We could just say, hey, pass an asset name here, right? And we'll just load it up that way. But along with the asset, we're going to need to know what package the asset's in, which should be known by the configuration. So we're going to need to know the asset name, the package name, and the type of asset that we're going to be loading, right? And then we're also going to need to know things like the type of resource we're going to be loading, which I guess we could put, you know, key resource type here. Sure, we could put that there. Let me get rid of this for a second and that. So what we're really going to need to know, though, is like what assets are we going to need, if any? Because we might potentially have resources that don't require assets, but there also might be some additional configuration that maybe we need to pass along with it. So we need something that's fairly open-ended to describe all of this. So I think we might need some sort of structure that's fairly open-ended that can describe this for us. So I think I'm going to put here, we're going to do type def, another structure, and we're going to say key resource request I don't really want to say configuration. Info, I guess. Info or data, I guess it doesn't really matter. K resource request info. Sure, we'll stick with that. And so to this, we could we can add some generic stuff that we know that we're probably always going to need, right? So one thing is we're probably going to have like an array of assets that we need, for example. So let's go ahead and include our new array that we just wrote. So that's going to be in containers array. And up here, we're actually going to declare that. So we're going to say define. Is it really not picking it up? It is define array, right? Or was it array type? I think it might have been array type, actually. Yeah, array typed. Array type. All right, so the type we're going to have is kname. That feels... Nope, it's not going to be kname. It's going to be something a little bit different. It's going to be another structure, actually. Type def. Struct. We're going to say k resource request and we'll say asset info. K resource request asset info. There we go. All right, so this will actually contain a K name, asset name, and then K asset type, and what did I say? Package name also, right? So K name, package name, right? So we'll need to know those three types of data to be able to request the asset. So we'll need to say array type, and we're going to do K resource request asset info. Okay, and so that's going to create a new array type for us. That's going to give us that fixed sort of array type that we generated here before. So it basically expands to this, right? We'll do K resource request asset info array, right? So we get an array with an iterator, and we'll say assets here. And this will need to be filled out by the caller, which I think is fair enough. The caller will know, how large that array needs to be. The caller will know how many assets there are, so forth. So we know that anytime we request a resource, there's probably going to be assets. We don't know how many, but we probably know there's going to be some. The other thing that I'm trying to think, is there anything else that we could probably know that's kind of generic? Thank you for the follow, by the way. Psycode, good to see you. How's it going? Resources. I actually have written a struct name that was not my proudest moment. Yeah, I've done the same thing. Resources. In this case, it was only a comment, and I was just like, okay, I can't even bring myself to do it there. But yeah, I've done it before. Let me think. So is there any sort of generic resource request info that we might need to know? I don't think so. Other than some sort of callback to say, hey, when an asset's loaded, who do I tell that the asset is loaded, right? Because remember, asset requests are asynchronous. So we're going to need some way to communicate that back to the resource handler of, hey, here's an asset that's been loaded, right? And then the resource handler can say, hey, okay, out of these assets, we have this one loaded. We're still waiting on this one. So we just keep waiting until we hear back from this other one. And, oh, hey, we've got all the requirements met to be able to actually load this thing up. Now we can go ahead and start loading and kick over to the next phase. You forced yourself to change that one because you cringed too much every time you looked at it? Yeah, that's fair enough. I probably would have too. So I guess we're going to need some sort of callback for that, right? So we do have in our asset system the old user callback that we kind of defined whenever we request an asset. It's this guy right here. So whenever we have a asset result, right, we make this callback. So we're actually going to use this guy as our function pointer to say, hey, whenever we've loaded one of these assets, we need you to call this. So let's see. I guess we could do. I think I should be able to do this. I don't know if I'm going to be able to say. I don't know if it's going to pick that up. Do I have the right things included? I do. Because it's in K asset types, which I think we do have here. Okay, perfect. All right. So let's just put in here the callback made whenever one of the listed assets is loaded. And then we'll say here, the list of assets to be loaded. Perfect. All right. So we know that we're always going to need those two things whenever we request a resource to be loaded. We're going to have to request assets for that. We may need to provide other contextual data that we don't know about to the actual resource handler, which is what we're going to call the individual thing, for lack of a better term, that is going to handle each individual type of resource. So in this case, we're just going to want to keep this super open and have it be up to the caller and the resource handler to know how to fill this out, which I think is perfectly acceptable, right? Because the general idea here is that this is needed if it's extra, but we're going to try and avoid using it unless absolutely necessary. So we're going to say here, I guess we'll do U64. What do we want to call this? I guess let me think about this for a second. I guess we could call this additional data size, right? And then void pointer additional data, right? And this is just going to be a void pointer. It's just going to be like open-ended. And it should be known how to cast that on both sides of the equation, right? I don't think we're going to need that all that much, but I'm putting it there in case we do. Because I don't want to architect this whole thing and then have no way to actually pass something like that through. All right, so let's just think about end to end here. So when we make a request, I'm actually going to go back to K-resource system here for a second. So when we make a request, we're going to want to do K-resource request info, right? We're going to take a copy of that. I think that's safe. So we're going to say we want to request an asset, or we want to request a resource, rather. Here's its name. Here's its type. So from there, we can deduce what resource handler to pass this request off to. Here is all the info that we need to process that request, contextual info. And here is a pointer to the resource that we're going to be processing. So this internal system would then need to say, okay, let me hand this off to the actual handler. That handler then says, okay, let's kick off a request to load these assets. Whenever one of them loads, we make this callback, which is passed here. That callback will contain, by the way, it will contain the result of the request, a pointer to the asset, and then a pointer to the listener data, which can be passed along with the original request. So listener data would be like the instance of something that we actually want to pass this off to. So, for example, we would probably pass the resource as the listener there, and that's how we would actually handle that. Or maybe we pass some structure with a pointer to the resource handler and the resource itself within that structure, and maybe that's the listener context, right? We can build that within here and then pass it through. So this callback is made anytime one of these assets loads. If there's more than one, obviously it's got to wait on them all to come through. And then at that point, the loader can change the state of the resource, which would pass via pointer to initialized, and then we could then kick off any GPU uploads that we need to do via the render, etc., etc., etc. That should all be handleable via this callback handler, which can then kick off other stuff. And we can jobify all of this stuff as well to kick off jobs. So that way it spins off on another job thread and we don't have to sit there and hold up whatever thread this came from. Let's see. I appreciate the follow. Thank you very much. Thank you for following. All right. So I think we have enough contextual data there. Arguably, we could do without these, but I think it makes a little bit more sense to include them. So the other thing that we're going to have as part of the resource system is we are going to have reference counting within the resource system as well. So whenever we request a resource, we're going to increase that internal reference counter by 1. And then whenever that resource is released, which is what we're about to write, that would be decremented. And then once that hits 0, the resource would be released from memory, unloaded from the GPU, all that stuff. So we'll do KAPI. I don't really think, like, if we fail to release a resource, like, I don't know what we're going to do about it except write a log. So we're going to say resource system release. And I just realized, actually, one parameter that we're missing here is we need the struct k resource system state, right? So we need that there, and we also need that, oops, off by 1, we need it there. So when we release that, we need the state, and then we need the k resource. And we're going to take a pointer to that, actually. And that's going to be the resource to be released. So that'll handle that. And let's see, is there any other... I don't think we need an update loop for this, because all this stuff is going to be driven by events and job callbacks, right? So I don't think there's any sort of spin that we need to do to keep things moving here. So I'm not going to opt into the update loop on this guy. So all we have is initialize, shutdown, request, and release. I guess the other thing that we need to start thinking about is the resource handlers themselves. So as we've talked about, we have different resource types here. And we also have this one down here that's custom, right? Or maybe we should say, you know what? I'm going to get rid of custom, and here's why. Because we're going to do this. We're going to say, here's the k resource, or the k resource type count is going to come right after the last resource. And then after that one, we're going to have one more, which is going to be the k resource known type max. And we're going to set that one to, I don't know, 128. I can't picture us ever having 128 resources, resource types. I don't think that's going to happen in the core engine. We probably won't have more than 50 or so max. But let's go ahead and block it off, right? So what we're going to say is anything beyond 128 is user defined types, right? So whenever a user wants to make their own resource type, they would just pick a number beyond this. The only thing that will have to happen with that is we may wind up taking like a string instead of using this type. But that's what I'm going to go with for now. we'll see how that works out when we start having external resource types that are maybe only implemented in like a plugin or something like that. Let's see. Is the listener just a void pointer in the callback struct? And if so, will the requester be responsible for inferring the type? Yes, exactly. It is just a void pointer because that type could be a lot of different things. And so the listener could theoretically be a resource handler. But the way that I'm trying to structure this is like if you, for some reason, wanted to request a resource manually in your game code using this, you could theoretically do that. So if you wanted to have some sort of super special case, like, yeah. So I'm trying to keep it a little bit open. I'm trying to think about that as well. At least where possible, right? Trying to keep from coding ourselves into a corner when it comes to that kind of stuff. All right, so initialize, shutdown, request, release. I don't think we need anything else. I think that's literally all our system is going to do. Oh, wait, no. Resource handlers. Resource handlers need to be able to register with this system. But we need to define what a resource handler looks like. And I think it's safe to define that structure here because any resource handler is going to be interacting with the resource system. So we're going to say k resource handler. And this is going to be pretty straightforward stuff, I think. We're basically going to have a function pointer, which is going to be let's see, I guess it'll be return type of Boolean, and we'll say request. Yeah, I don't want to use the term load because there's technically two different loads that happen within a resource request at minimum. So we're going to say request. And to that, we're going to pass through the resource itself. Which by this point will have its name and type filled out because we'll do that at the generic system level when we do this. And then it'll also need the k resource request info. Right? And then also it's going to need a reference to itself as well in case we have any sort of data that we need to store in here. So we're going to say struct k resource handler self. Right? So our handler is basically going to be a function pointer. We've kind of followed this pattern with our asset handling as well. And then, so we have a request, and then we have void release, which again is just going to take struct k resource handler self, and then k resource. And that should be sufficient, I think. Yeah, that should be it. So the last piece of this would then be, and we need to expose this one too, or export this symbol. I guess we'll do a B8 in case this fails, right? If you try to register the same type more than once or something. We'll say key resource system handler register. Right, and so we need to struct k resource system state, and then we'll do I guess the type, right? So k resource type, which will be type, and then k resource handler handler. And what we'll do is right before we're going to pass that by copy, right? We're going to pass a copy of that on purpose. So we'll basically configure one of these things somewhere, set it up with a function pointer and all that stuff. We'll pass a copy so we don't have to worry about the lifecycle of it, because it's only just a small struct with a couple things. So we'll say take this handler, register it for this type, and then here's the state where we actually store all that crap, right? If we already have a handler for that type registered, we're not going to allow more than one handler for a type. So if the user tries to do something stupid, we'll block that and return false. But that's the only case I think that we would return false, unless, of course, we don't provide state here. That is, I think, going to do it for our new system. It really is that simple, I believe. I don't see the need to make it any more complicated. So we're going to handle this just like assets, where all we do is make a request. And then it's up to all of the callbacks and stuff that are issued to respond appropriately once that time comes. And I realize I just missed an ad break, but it is what it is. If the user can do something stupid, they will. It's an unwritten rule. And I would say even written. It's written many times. Diamond, how's it going? Good to see you. All right. So I think I'm pretty satisfied with the way that this is looking, actually. So I guess let's take all of this stuff, move over to the C file, and start implementing it. K resource system C. So obviously we need to include, whoops, if I could spell it right, K resource system. And then let's just paste this stuff. All right, and also we need to now come up here and do a typedef struct k resource system state. And we need to actually define what this thing looks like internally. K resource system state. There we go. So this is going to have, we're going to have to use our old style D array here. No, we're not. Actually, we are going to use a array of handlers indexed by type, which will give us a lightning fast lookup. Yeah, let's do that. So we're going to have K resource handler. We're going to have an array of those, which is going to be, let's see, K resource type count. And we're going to call this handlers, I guess. Right? So all we have to do is handlers and then look up by type. And we're basically just going to copy the function pointers here to that. So actually we could just do this real quick. So if not states, then k error k resource system handler register requires valid pointer to state. Return false. All right, and then what we can do is if state handlers sub type request or state handlers. You know what? Let me not. That's kind of dumb. Let me actually Let me do k resource handler pointer h equals address of state handlers sub type, right? And then we'll do if h request or h release. Then we're going to do k error. A handler already exists for this type. We should probably get string information as to the type, but I'm not going to worry about that for right now. I'm just going to return false. Suppose I could assert that too, but whatever, we'll stick with this for now. Otherwise, we'll do h request equals handler request, and h release equals handler release. Turn true. That's all there is to registering a handler. Very simple stuff. All right, so initialization, I guess, is what we should probably handle next, right? So the way that this works is this follows the old call it twice pattern. Once to get the memory requirement, and then the caller of this should initialize some memory, and then pass it again with state having been defined, and then we go from there. So what we're going to do is we're going to say memory requirement. Well, actually, if we don't have memory requirement, that's an error, right? So you know what? That's dumb. Let's just assert this. K assert message. Memory requirement, right? Valid pointer to memory requirement is required. All right. So if we have that, then we're going to do memory requirement, right? The dereference of that. We're going to set the value of that to size of k resource system state, which we only know once we get here because we're keeping this internal, right? So we have that. And then if at this point we don't have state, that's fine. Return true, because all we're doing is getting the memory requirement at this point. If we do have state, then we do to do configure state, etc. We don't have any of that for right now, so all we're going to do is return true. As if to say, you know, our configuration's good, we're all set up, we're ready to go. Obviously, there's going to be a lot more to this once we start setting up the reference counters and stuff, but we're not there yet. And then our shutdown, we're just going to say if state, right? And then to do release resources, etc. Okay. So what we're going to do here, and this is the other reason we're going to track all of these resources, is because if our game code does not release this stuff, Vulkan bleats if you basically don't get rid of like GPU resources and stuff. So by the time we go to shut this system down, if we have anything that's left in here that's still loaded, that an unload hasn't been called for, we're going to go ahead and unload it at this point. That way we don't actually miss anything, right? So our resource system will be shut down before our renderer does. So that's what that's for. Why is the K resource system state externally managed and not owned by this translation unit? Because its memory is allocated by the core engine, where all of our other systems' memory is located. And the reason I do that is because we have a central place that stores all the state for all of our systems, which A, makes it very easy to get that state from anywhere, and B, keeps it from being in a place like that's within hot reloadable code or something like that where it could change. So we literally have just a function that we can call for our engine to say, hey, give me the collection of all the system states you have, and then we can very easily get that memory. So if we are in, I don't know, if we're loading up a scene, for example, right? And we need to load a static mesh, right? I don't want the scene to have to like hold the state for this system, for example. I want the scene to just be able to go, hey, engine, can you give me the state for this system real quick so I can make this call, right? And this allows me to do this without actually having to have like a private static pointer to state in this translation unit. Because I used to do it that way, and a lot of systems actually still work that way, and I'm trying to get away from that because I don't want to have a static pointer in here that's like the state pointer thing that you've seen in other parts of the code base. We're trying to get away from that. I hope that answers your question. All right, so that's that. In terms of request, this is going to be pretty straightforward too. So obviously, if we don't have states, you know what? I'm just going to assert that at this point. States. We need states and we need out resource. And out resource, right? And then we're going to say valid pointers to state and out resource are required. All right. And then what we'll do here is we'll say out resource and name is going to be equal to name. Out resource type is equal to type, right? Can we set anything else up? State, actually, yes, is resource state. Oops, it needs to be k resource state uninitialized, right? That's where we're starting. Let's see. Generation equals invalid ID, right? Resource, what else can we set? I think that's it for now. We're not doing anything with tags yet, so I suppose we could still zero it out though. Tag count equals 0 and out resource tags equals 0. We'll just do that for right now. All right, so we do all of that. And then what we'll do is we'll say if state handlers sub type dot request, right? So if there's a handler set up for it, actually let's let's do the same thing as we did down here. Reason being, if we don't have this, that's actually an error, right? So there is no handler set up for the asset type. Return false. All right. We need to include some more information about what the type is, but we don't have our string conversion function yet. We'll get to that. So thank you for the follow, by the way. So we have that. If we don't fail there, then we're going to say h request, and we're going to, I guess, oops. Let's see. We need to pass along the handler and the resource. So we need h and then out resource. And then info, I think that's it, right? And then we're going to return that, right? So this request returns immediately, and that's basically saying, are we able to make the request? Yes or no. It's not that the request was completed, it's just, are we able to issue that request? So we can return that as the result. So that's basically what that looks like, right? So once we start setting up handlers, that's what actually drives all of this. And then release. Oh, right. There is one more bit. Let's split this off. We're gonna say B8 result equals that, right? And then we're gonna say return result here. But then we're gonna say if result. We're going to do increment reference counts. And here we're going to say if, I guess I could just assert both of these again. Message, so state and resource. K resource system release requires valid pointers to state and resource. Okay, and then what we'll do here is we'll do decrement reference counts. If this reaches 0, release resources, unload, etc. Right? So we don't have that reference counter yet. But what I can do is say if state, actually, let me just, again, follow this same pattern here. Right, so we can say, whoops, I forgot to grab this. So we could do handlers instead of type, we have to do resource type, right? And then obviously we're just going to spit an error, and then we'll do else here. And this shouldn't be request, this should be release, right? And then we do h release. And I think that just takes the handler and the resource. And there we go, right? So that is pretty much, I think, the meat and potatoes of this, minus the reference counting, right? We'll get to the reference counting another time, because it is getting kind of late. So, yeah, I think we've made decent progress tonight in terms of mostly, honestly, figuring out how we're going to make this whole thing work. We wrote some code. We didn't write that much code, I guess, but we did actually, I guess, figure out how this should work, which is, I think, the most important thing. So we also have scaffolded what our interface for our handlers are going to look like, and we have a way to register those. So next time we can actually set up our first handler, which is going to be for textures, which is going to be interesting because that is also going to have to work with the texture system, which is also going to have some sorts of updates. So I'm actually thinking this might wind up replacing about 90% of the texture system, actually. Because it's going to have reference counting in here already, so we don't need the texture system to do that anymore. It's going to handle all the loading of stuff to the GPU, which the texture system also does, so it's not going to have to do that anymore. I think the only thing that the texture system might have to do is maybe provide defaults. And we don't need a system for that. That could be simply just a few, like, utility functions, I think. So we might actually be eliminating our entire texture system with this, believe it or not, which is pretty cool, I think, because I like eliminating code. I like adding code, of course, but I like eliminating code as well. All right, so that is going to do it for tonight. This is where we end. I do want to say thank you to everybody who has joined me here live. I really do appreciate you guys. If you haven't already, I would greatly appreciate a follow either on the Twitch side or on the YouTube side, or both. That would be even better. Appreciate that. Just helps me grow the channel and spread the word of what we're doing here. If you know anybody that's interested in this kind of stuff, that might find this interesting, feel free to spread the word there as well. I really appreciate all the new folks. Welcome everybody. I hope you guys enjoyed. And let's find somebody to raid. So let's see. I want to see if I can find somebody that's doing something kind of similar to what we're doing. Have mixed luck with that sometimes. We'll see. Okay, I'm going to have to... let's try a category here. Narrow it down a little bit. I see somebody that I could raid. Although I just raided them, so I don't know. Let's see. Let's, I'm still scrolling through the list to try and find somebody to raid. Well, I'll tell you what. Let's do this. Let's bring this over. And if you guys see anything that looks interesting to you, I guess, shout out in chat. I'm going to open, let me just, open another window here for a second. Bear with me just 1 second here. Because unfortunately this window blocks chat, so I have to open up another dashboard so I can see what the heck we're looking at here. So I can actually see when you guys say something. All right, so let's see. So Kuju I've rated a lot. I rated him last night actually, so we might go that route if that is interesting to you guys. I'm just trying to see if there's something else here that sort of maybe you guys know or something that looks interesting to you guys that we could do. Probably not somebody who is only like ASMR, I'm guessing. We've rated Jitspo a lot too. Okay, this guy has dingus as a tag. I mean, yeah, I don't know. That might be... might rate him just based on that alone, honestly. Let's see. There's not a whole lot of programming streams on. By the way, if you guys see anything that looks interesting, feel free to speak up. Let's see. Wayward Game. There's some TypeScript game dev here. I used to do some of that on my channel years ago. So maybe that's something we could look at.
Let's see. Boy, it is actually kind of hard to find legitimate, like, because a lot of it I think is like level design, which doesn't necessarily, it's not like a programming stream. Florida Man C64 retro coding. C64, I wonder if that means, if it's retro coding, that's probably Commodore 64. That might be interesting. Go to Florida Man? Yeah, I think we're going to do that. I think that is, how far up was that? Go to Florida Man. I see what you did there, by the way. Did I scroll past it? I must have. Or it refreshed the, I think it refreshed the list. Let me, can I do, I don't know what his name was. I think it was way down here though, somewhere. Yeah, it refreshes, I think it just did it again. Super annoying when it does that. Because it was pretty far down on the list. I think probably because he didn't have a lot of viewers, which is also a good reason to rate him. Okay, I know it was below this. Where was that? Oh my god, I think it just did it again. Alright, I'm going to have to scroll a little faster, I guess. Super annoying when it keeps doing that. Here it is. Got it. All right, so we are going to raid them. And yeah, ask him what he's working on. And yeah, thank you guys for being here. And we will catch you guys on. Oh, I should probably hit the start raid button. There we go. All right. We will catch you guys on the next stream. So thank you guys for being here. And yeah, we will catch you next time. I'm going to go ahead and start the raid now. See ya.